Good day, everyone. This is Ma'am Jo, and welcome to another video lesson discussion in statistics and probability. So for today, we're going to have the standard scores or the C-scores. And these are the objectives of our discussion. And these are the questions that you should be able to answer at the end of the discussion. Okay, a raw score or X values provides very little information about how that particular score compares with the other values in the distribution. For example, if you get a score of 53, that score could be relatively low, extremely high, or simply just an average score compared to the other scores in the distribution depending on the mean and the standard scores. So if we want to know the exact location of that score relative or compared to the other scores in the distribution, we can convert that raw score into a C-scores. Standardization or putting scores on a test into a form that you can use it to compare across tests. These scores become known as standardized scores. So to convert a raw score into a C-scores or standardized scores, we can only do that when the set of data values are normally distributed. So what are examples of standardized scores? So the score that a person got in his or her licensure examinations, for example, board exam for being a teacher, an engineer, a doctor, a CPA, an architect, and the likes, those scores are standardized. So for students, we have the National Achievement Test and the National Career Assessment Examinations. So those are examples of standardized scores. So what is a standard score or a C-scores? So it is a measure of an observation's distance from the mean. Usually we use the standard deviation as the units. So it is a measure or it reflects how many standard deviation a given value or raw score is above or below the mean. So this is how we define a C-scores. Okay, and this will be the formula in converting a raw score into a C-scores. So the definition of C-score is the same for both population and sample. And the formulas are also the same except that for sample mean, we use the X bar for the symbol and we have the mu for the population mean. For the standard deviation population, you have the sigma, and for sample, you have the symbol S. And then Z is your C-scores or standardized scores, and X here represents your raw score or observed values. So either formula, you can use it. You just be careful with the symbol that you're going to use for population and for sample. Now, the process of changing a raw score into a C-score involves creating a signed number. So the sign of the C-scores will identify the location of the raw score. So if it is positive, that is above the mean, and if it is negative, that is below the mean. So the numerical value of the C-score that will correspond to the number of standard deviation between the raw score and the mean of the distribution. Okay, one of the importance of C-scores is that it's very useful in comparing observed values. So it makes it easier to compare data values that is measured on different scales. As I've said earlier, when the C-score is positive, it indicates that the raw score is above the mean, and negative will indicate that it is below the mean. When the C-score is exactly 0, your raw score is on the mean. Thus, a score that is one standard deviation above the mean will have a C-score of positive 1. And a C-score of negative 2 always indicates a location below the mean by 2 standard deviation. So that is how you interpret a C-scores. I hope that is clear. Okay, let's have an example. On a final examination in biology, the mean was 75 and the standard deviation is 12. Determine the standard score of a student who received a score of 60 assuming that the scores are normally distributed. So what are the given? So we have here, you are asked for the standard score or C-score, so that will be your Z. Your raw score is 60, that is your X. So here we use the symbol for the sample mean, which is 75, and the standard deviation for S, that is 12. So applying the formula for the sample C-scores, so we will have this formula. And by substitution, that will be give you 60 minus 75 divided by 12. So that is negative 15 divided by 12. In decimal, that will give you Z is equal to negative 1.25. So to interpret that, since our C-score is negative, therefore this mean that 60 is 1.25 standard deviation below the mean since it is negative. Is that clear? Okay. Okay, now using the normal curve, we can locate the exact position of the raw score and C-scores that we have in problem number 1. So the given there is your mean is 75 and the standard deviation is 12. So the mean is at the middle, so that means that is 75 and the distance is 12 standard deviation. So that means to the right, one standard deviation, we simply add 12. So 75 plus 12 is 87. And if we continue adding 12, that will be equivalent to 2 standard deviation and the raw score is equivalent to 99. Now to the left, we simply subtract 12. So 75 minus 12 is 1 standard deviation to the left and the raw score is 63. We convert 60, the given value is 60, your raw score, and that is equivalent to 1.25, negative 1.5 sa C-scores. And we know that that is the location of 1.25, and 0.25 is 1/4 of 1 standard deviation. So, apat na hati. So, since the distance is 12, so we divide it by 4, so you have it 3. So, therefore, 63 minus 3, so this position will be, this is the score 60, and it has a C-scores of negative 1.25. Is that clear? Okay, so I hope now you can visualize and fully understand how a normal curve or how a raw score is converted into a C-scores. Okay? And how you can locate it in a normal curve. Okay? Okay, so let's have another example. On the first periodic exam in statistics, the population mean was 70 and the population standard deviation was 9. So determine the C-scores or the standard score of a student who got a score of 88, assuming that the scores are normally distributed. So again, what is our raw score? Okay, that is 88, correct? Your mean is, okay, 70 and the standard deviation is 9. So here it is indicated that it is a population population ang ating given. So using the formula for the population C-score, so we'll be using this symbol. And by substitution again, so that will give you 88, your raw score, minus 70 divided by 9. So 88 minus 70 is 18 divided by 9. So that will give you 2, exactly 2. So therefore, since it is positive, our conclusion will be 88 is 2 standard deviation above the mean. Okay? Did you follow? Okay. Now, to locate the position of your raw score, so again, the mean is 70, so that will be at the middle, and your standard deviation or the distance is 9. So to the right or above, you just add 9, and then that will be 79 for one standard deviation, and another 9. So this will be the location of your raw score of 88, which is 2 standard deviation above the mean. Is that clear? Okay, so to the left, you just simply again subtract 9. So 70 minus 9 is 61. That is 1 standard deviation below naman. Okay? Okay, let's have this problem. What will be the miles per gallon for a Toyota Camry when the average miles per gallon is 23? It has a C value of 1.5 and the standard deviation of 2. So here, average again, guys, that is another term for mean, so that will be the value is 23, and this time the Z-score is already given, which is 1.25. You are asked to find the number of miles per gallon. So that means we are looking for the value of X or the raw score. So this will be our given. Okay, so the mean is 23 and your standard deviation is 2. So using the formula, either formula you can use it, and by substitution, we will have this one. So 1.5 is equal to the raw score minus 23 divided by 2. So all you have to do is to cross multiply. So 1.5 times 2, that will give you 3 is equal to x minus 23. And then we just simply transpose 23 to the other side, or negative 23. So that will give you x is equal to 26. And therefore, the Toyota Camry would be expected to use 26 miles per gallon of gasoline. Okay, so that will be the conclusion. Is that clear? Okay. From the formula of the C-scores, so okay, the terms here can be regrouped so that we can derive another formula in finding this time the raw score. So this is your formula. So we just simply cross multiply this one and then you transpose population mean. So that will give you X, so your raw score is equal to population mean plus your C value times the standard deviation. So this is the formula that we use in problem number 3, finding the raw score instead of the C-score. Is that clear? Okay. Since C-scores can identify the exact location of a scores within a distribution, that means that score can be used as descriptive statistics and as inferential statistics. So as descriptive, the C-score will describe exactly where each individual is located. And as inferential, C-scores will determine whether that specific sample is a representative of its population or it is extreme and unrepresentative. So if it is nearer the mean, the score is nearer the mean or compressed at the middle, that means it is a representative. If not, that means they are extreme values, whether too low or too high. So that is what you mean in inferential statistics. It will determine whether it is a representative, that sample is a representative of the whole population. Is that clear? Okay. Okay, so another importance of C-score is that when you transform an X value into a C-scores, so the resulting distribution of C-scores will still have a mean of 0 and a standard deviation of 1. And the transformation does not change the shape of the original distribution, and it does not change the location of any individual score relative or compared to the others in the distribution. That means the distance is in a normal curve, so you still have one standard deviation as the distance. So whether you change the X values or the raw score and you change the distance or the standard deviation, you can still locate it in the normal curve. Okay, so that is how important transforming a raw score into a C-scores. Okay, to understand the importance, let's have this example. A set of math test scores has a mean of 70 and a standard deviation at 8. And then a set of test scores has a mean of 74 and a standard deviation of 16. For which test would the score of 78 have a higher standing? Okay, so let's have the solution. Okay, so for the math test scores, we have the following values. So the mean is 70 and your standard deviation is 8. So applying the formula in finding the C-scores, so we just simply substitute. So 78 minus 70 is 8 divided by 8. So the C value is equal to 1. For the English test, the mean is 74 and the standard deviation is 16. So again, by substitution, 78 minus 74 is 4 divided by 16. So that will give you 0.25 or 1/4 of the standard deviation. So, but the question is, for which test would the score of 78 have a higher standing? So if you will notice, if you're going to compare, both scores has a positive C value. So it is above the mean. But since the math test has a C value of 1 and this one is only 0.25, so therefore we can conclude that the math score have a higher standing in the test compared to the English test. Okay, so since they are both positive. Okay. Okay, to illustrate it in the normal curve, so a math test has a mean of 70, the standard deviation is 8. So from 70, we add only 8. So this is the position of your 78, which has a C value of positive 1. Okay, for the English test, the mean is 74 and the standard deviation is 16. And we convert 78 as the raw score, and the C value is equal to 0.25, and we know that 0.25 is only 1/4 of the distance from the mean. So our standard deviation is 16, so 16 divided by 4, that is 4. That's why you have 74 plus 4, so this is your score, 78, and the C value is 0.25. Okay? So you will notice here that if the C value is positive, okay, the farther you are from the mean, the higher is your standing. Okay? So, but if you have a negative C value, if you have here a negative C value on the left, so the farther you are from the mean, the lower is your score. So, that's why, again, 78 or the raw score 78 has a higher standing in math than in science. Is that clear? Okay. Okay, that ends our discussion for today. Visit the Google Classroom for your output and kindly subscribe, like, comment, and share. Thank you.